Okay, this is the new movie that I make in order to continue the previous movie. Ending our previous movie, we had one table, contingency table, based on the table of based on the contingency table. We had question one. Okay, we had question one, and we only found the answer of that question one. Now this movie, based on the same table as previous movie, we have question two. So this is question two. What is the probabilities of randomly selecting an executive who is loyal to the company? Loyal to, it means would remain with the company, or who has more than 10 years of service. So by looking at this, the difference between question 1 and question 2 is question 1 or and question 2 or. Okay, so we know answer question 1. Now we're going to see answer question 2. So this is the probabilities of A1. A1 would remain. B4 work more than 10 years. So probabilities of A1 is the same thing as question 1, 60% or 0.60. But the probabilities of B4 for question 2 is not the same thing as probability of B4 in question 1. B4 here equal to probabilities of more than 10 years. Okay, executive who work more than 10 years or more than 10 years of service. 105 divided by 200. Why is it 105? This one. Why is 105? 105 B4 over 200. Why not 75? Because we just want to see A1 or B4. Okay, A1 or B4, not A1 and B4. That's why A1 and B4 events are not mutually exclusive, because we're talking about or about additive. This is additive, not multiplicative. Okay, this is I just make a difference between and is multiplication, but or is addition or addition. So the probabilities of A1 or B4 equal to probabilities of A1 plus probabilities of B4 minus joint probabilities of A1 and B4. Okay, so based on the table, 75 executives remain with the company and 10 years of working service and 10 year working service. That's why this is 0.60 375. Okay, so 75 remain and have more than 10 years. So this one. So the answer is 0.75, because we want to see would remain or more than 10 years. It means that when we randomly selecting one executive, if he or she say yes I remain, okay, it satisfies our condition. Or he or she working more than 10 years, okay, or satisfy our condition. That's why these two conditions is one satisfied, yes, we can find the result. Not both of them. But in terms of question 1, unless both of them satisfied. If both condition or both ever not satisfied, we cannot find answer for question 1. But in question 2, if one event satisfied, yes, we can find. Okay, so say yes, okay, or work more than 10 years, okay. So this is the answer. So you can see this is different from question number 1 answer. Okay, so do cell review 5.7 on this page 164. Okay, we can go there. 5.7. This 5.6 previous movie. Yes, we have example. You can see example, but this is similar. This is the same example that I take in the slide. That's why I'm not asking you to study again. But if you are not sure for my explanation, because this is too long. See, it's long, but my slide is short. I take a short. But if you not clear, you are not clear about question number 1. This is only question number 1, not question number 2. This is question number 1, not number 2. Okay. So if you are not clear about question number 1, you can go to see example on page 163. This is for question number 1. Okay. Cell review 5.7, this page 163 and 64. So you can do this one. Next, we will go to tree diagrams. Okay, we can go to tree diagram. This is tree diagrams. What does it mean? A diagram is like a tree. So we have tree, we have a stem, we have a branch, we have leaf, something like this. Okay. A tree diagram is a graph that is helpful in organizing or displaying our calculations that involve several stages. Each segment or each stage is in the tree is one stage of the problem. Several stages, that means several problems. That's why one stage represents one problem. The branches of the tree diagram are weighted by probabilities. Okay, are shown by probability. A tree diagram is useful for displaying or portraying the conditional probabilities and joint probability together. So when you have tree diagram, you need to show the probabilities of conditional and probabilities of joint. Okay, so tree diagram will show you two probabilities: conditional probabilities, joint probabilities. Joint probability when we study general rule of addition. Conditional probability when we study general rule of multiplication. Okay, it is particularly useful for analyzing business decisions involving several stages. Okay, if you want to make a choice, you want to make choice or you want to make decisions by using several stage, several step, or the several problems, so we can use a tree diagram. Based on previous question number 1. Okay, based on previous question number 1, we can construct, we can develop, we can make tree diagrams are follow. Okay, nothing here. Why did nothing? Yes, because we do not just showing. Okay, remember what is question number 1? Question number 1: what is the probabilities of randomly selecting an executive who loyal to the company, that means would remain the same, and who has more than 10 years of service. So loyal to company A1, more than 10 years B4. But N, that's why under condition of A1. Okay. So this is question number 1. Okay, go to tree diagram. This is when we ask 200 executive about whether this executive still stay in this company or move to new company. If they answer they would remain, so we put them A1. A1 is the event of answer stay the same or remain the same in the company. That's why based on contingency table we found that 120. If some executives say not remain the same, not remain with the company, not remain with the company, it means they move to new company. Based on contingency table we can see of 80. Okay, so A1 stay the same, A2 move to new company. That's why it's about loyalty here. It's about loyalty. Among the one who say remain with the company, they have different lengths of service. 10 less than 1 year, working less than 1 year. This is conditional. Why is it conditional? This is happen unless they are remain. That's why this is happen unless they are remain. You can see this is a condition. Without remain we cannot find this one. That's why 10 work less than 10 years among the one who answer remained. 30 work 1 to 5 years among executive who say remain. 5, 6, 10 years among A1 would remain. 75 among the one who answer would remain. That's why this is called conditional. So probability of B1 unless A1 comes first. Probabilities of B2 unless A1 comes first. Probabilities of B3 under condition or given that A1 comes first. Probabilities of B4 unless or under condition or given that A1 comes first. That's why if we take probabilities of A1 multiplied by a conditional probabilities of B1 or B2 or B3 or B4, we will get joint probabilities. What has been joint probabilities is a multiplication of two probabilities together. This is called joint probability. Okay, joint probability we study rule of addition under under general rule of addition. Okay, this is for one part that we will look at that display you under the condition of or given that the answer of executive would remain. How about the other? Move to new company, would not remain, move to company. The executive that move to new company would not remain also have the same thing in terms of services, length of service. In this case, B1 less than 1 year, 25, B2 1 to 5 year, 15, B3 6 10 year, 10, B4 over 10 years, 30, 15, 25, 15, 10, 30 under condition of A2. That's why when we take probabilities of A2 multiplied by probabilities of B under condition of A2, this is called joint probability. When we add all of these probabilities, when we add all results from joint probability together, equal to 1. Okay, it's equal to 1. Okay, equal to 1. So see again and again, because you have cell review 5.8 and exercise. Cell review 5.8. This is tree diagram. You can read the textbook. This is the same thing I show in my slide, and I make one part by part, but this is show all. This is a cell review 5.8. Okay, you have 2 questions to answer. Okay, homework. Homework 24, 26, 28, 30. Okay, but 30 I have some note for you here. You can find something here. Okay, this is not 32, no 32. So homework for this week 24, 26, 28 and 30. Now it's time for you to watch this movie and work. Okay, and if you have some questions, some unclear points, you can contact me.